Hey everyone, welcome back to the channel. Today, we're diving into one of the most exciting fields in technology, machine learning. If you've ever wondered how Netflix knows exactly what show you want to binge next, or how your phone recognizes your face to unlock, you're in the right place. Let's break down the fundamentals in a way that actually makes sense. So, what exactly is machine learning? Here's the simple definition. It's our effort to automate intellectual tasks that are normally performed by humans. Think about it. When you see a photo of a cat, you instantly know it's a cat. When you hear a song, you can predict if you'll like it based on the first few notes. These are intellectual tasks your brain does automatically. Machine learning is trying to teach computers to do the same thing. But here's the million-dollar question that started it all. Can computers actually think? Well, that's still up for debate, but what we do know is that computers can learn patterns from data and make predictions, and that's pretty incredible. Here's where it gets really cool. Traditional programming works like this. You give the computer specific rules, and it follows them exactly. For example, if I wanted to program a computer to identify spam emails, the old way I'd have to write rules like, if the email contains the word urgent in all caps, flag it as spam. If there are more than 5 exclamation marks, flag it as spam. If it mentions Nigerian princes, definitely flag it as spam. But here's the problem. Spammers are crafty. They keep changing their tactics. I'd be updating rules forever. Machine learning flips this completely on its head. Instead of giving the program the rules, we give it data. Thousands of examples of spam and non-spam emails, and the algorithm figures out the rules for us. It's like having a super smart assistant that learns from experience. Now let's talk about neural networks, one of the most powerful forms of machine learning. Think of them as the brain's way of processing information, but simplified for computers. Regular machine learning, pretty straightforward. You have your input bubbles, that's your data. They go through a set of rules, that's your algorithm, and you get your output. It's basically just 2 layers, input and output, with rules connecting them. But neural networks, they're like the overachievers of the ML world. They have multiple layers between input and output. Your data gets transformed and refined through each layer before reaching the final answer. Imagine you're trying to recognize a photo of a dog. The first layer might detect edges and shapes. The second layer combines those into more complex patterns like ears and tails. The third layer puts it all together and says, hey, that's a golden retriever. This is what we call a multi-stage information extraction pattern. Fancy words for breaking down complex problems into smaller, manageable pieces. Here's something that might surprise you. In machine learning and deep learning, data is everything. I mean it. You could have the most sophisticated algorithm in the world, but if your data is garbage, your results will be garbage. Let me show you with a real example. Imagine we're trying to predict student performance. Here's a simple data set. Student ID, midterm 1, midterm 2, final exam. 1, 70, 80, 77, 2, 60, 90, 64, 3, 40, 50, 38. Now, let's say we want to predict midterm 2 scores based on midterm 1 and final exam scores. In ML terms, midterm 1 and final scores are our inputs or features, the information we're giving the algorithm. Midterm 2 score is our output or label, what we want to predict. The algorithm would look at this data and think, when midterm 1 is 70 and final is 77, midterm 2 is tending to be around 80. When midterm 1 is lower at 60, but final jumps to 90, midterm 2 is also high at 90. It's finding patterns we might not even notice. And this stuff isn't just theoretical, it's everywhere around us. When Spotify creates your Discover Weekly playlist, it's using your listening history as input features to predict what songs you'll like, as the output. When Amazon recommends products, when Google Maps predicts traffic, when your email filters spam, it's all machine learning working behind the scenes. The beauty is that these systems get better over time. The more data they see, the smarter they become. It's like having a student who never stops learning. And that's machine learning fundamentals in a nutshell. We've covered what it is, how it differs from traditional programming, why neural networks are so powerful, and why data is absolutely crucial. Remember, machine learning isn't magic. It's math, statistics, and lots of pattern recognition. But when you put it all together, the results can feel pretty magical. What would you like to see next? Should we dive deeper into neural networks or explore some specific algorithms? Let me know in the comments below. Don't forget to like this video if it helped you understand ML a bit better, and subscribe for more tech content that actually makes sense. Until next time, keep learning.